So let's talk about the distributed databases. Basically, in the distributed databases, the computers are actually at various sites. So, for example, let's look at the Premier Product Database, for instance. It could have multiple locations nationwide. Each location could actually have its own sales rep and customer base. And each location also, it can maintain their own inventory. And instead of using one single centralized computer that accessed by all the separate locations, Premier Products is actually considering installing a computer at each site. If it does it, each site would maintain their own data about their sales rep, about their customers, parts, and orders. So in the distributed databases, they are being connected with communication network or actually network. So basically, a distributed database is a single logical database which is physically divided among network computers, which is in this case, it's the case of the Premier database. Distributed database management systems, they basically support and manipulate distributed databases. This diagram shows you the communication network in a database, distributed database management system. Actually, computers in a network, they communicate through messages. So that means one computer could send a message to another one. A computer might send a message to request the data from another computer, or also a computer might send a message to indicate that there is a problem. Normally, to access data rapidly in a distributed database, we can attempt to minimize the number of messages. The length of time that is required to send one message, it can depend on the length of message, and also it depends to the characteristic of our network. A fixed amount of time that sometimes would be called access delay. And the communication time is equal to access delay plus the data volume over transmission rate. So this is the formula for message transmission time, basically. Now let's talk about characteristics of a distributed database management system. A homogeneous database management system is one kind, which is one that has the same local database management system at each site. We have also heterogeneous database management system, which is the one that doesn't. There are actually at least two sites at which the local database management systems are being different. In heterogeneous database management system, normally they are being complex than the homogeneous ones. And they also have more problems and more difficult to manage them. All the database management systems share some important characteristics. Some of the characteristics are location transparency, replication transparency, as well as fragmentation transparency. Let's look at the location transparency. We have actually a remote site, which is a site other than one where the user is. And then we have our local site, is where the user is. Location transparency, in that case, is the characteristic of a database management systems. That the user, they don't need to be aware of the location of the data in a distributed databases. Let's look at replication transparency. Data replication sometimes create update problems that can lead to data inconsistency. In the replication transparency, users are actually unaware of some of the steps taken by the database management system to actually update various copies of the data. So basically, the steps that are being taken by the database management systems to update their various copies of data should be done behind the scenes, and users should not be aware of the steps. Let's look at the fragmentation transparency. A database management systems, distributed database management system supports the data fragmentation. If the distributed database management system can divide and manage a logical object, such as record in a table, among the various locations under its control. The main purpose of the data fragmentation is to place data at the location where the data is most often being accessed. So this is the key. You want to put the data in a place that at the location where you are going to mostly access it. Fragmentation transparency is when users are aware of fragmentations. The users should actually feel that they are using a single centralized database. So in that way, it should be the distributed database management system should handle the fragmentation transparency. In this example, we are looking at the Premier products part table data. And in this example, we see the fragmentation of part table data by the storehouse. So let's look at some of the advantages of distributed databases. First, there is local control of data. Because each location retains its own data, a location can also have a greater control over the data. With a single centralized database, on the other hand, the central site that maintains the database is normally unaware of the local issues of various sites. Also, another advantage is to increase database capacity. In a properly designed distributed database, the process of increasing system capacity is normally simpler than the centralized database. If the size of a single disk at a single site becomes big or inadequate for that database, we need to increase the capacity of the disk only at that site. Another advantage could be system availability. When normally a centralized database becomes unavailable for any reasons, no user can actually continue processing or doing anything in there. In contrast, if the local databases, our local database is in a distributed database, and it becomes unavailable, only users who need data in a particular database are being affected. Other users can continue processing in a normal fashion. And another advantage of distributed database is that it can improve performance. When our data is available locally, we can eliminate network communication delays and we can retrieve the data faster with a remote centralized database. Now let's look at the disadvantages of the distributed databases. First disadvantage is that update of replication data. Replicating data can actually improve processing speed and making sure that the overall system remains available, even when the database at one site becomes unavailable. However, as we said, replication can cause update problems. So instead of updating a single copy of the data, the database management system must update several copies. Because most of these copies are at the sites other than the site initiating the update, each update transaction requires extra time to update each copy, and an extra time to actually communicate all the update messages through the network. So replicated data causes another more serious problem. Assume that an update transaction must update data in a replicated at 5 different sites, and that the 5th site is currently unavailable. If all the updates must be made or none at all, the update transactions fails, because the data at a single site is unavailable for update. that data is unavailable for update at all the sites. This situation certainly causes for the system to be unavailable. So normally the distributed database management systems designates one copy of the data to be the primary copy. As long as the primary copy is updated, the distributed database management system considers the update to be complete. The primary site and the distributed database management system must make sure that all the other copies are basically in sync. So as you can see, this is a little bit complex problem, and it is more complex querying processing as well. Processing querying is more complex in these type of databases. The complexity occurs because of the differences in time it takes to send messages between sites at the time it takes to access a disk. Also, sometimes deadlock is possibility in a distributed databases. In distributed databases, however, deadlock is more complicated because two types of deadlock, local deadlock and as well as the global deadlock, are possible. Local deadlock is when the deadlock that occurs at a single site in a distributed databases. If each of two transactions is waiting for a record held by another at the same site, the local database management system can detect and resolve the deadlock with a minimum number of messages needed to communicate the situation to the other database management system in a distributed system. On the other hand, global deadlock involves more than one site. Another disadvantage could be more complex recovery measures. The distributed database management systems uses something called two-phase commit. The basic idea of two-phase commit is that one site, often the site initiating the update, acts as a coordinator. In the first phase, the coordinator sends message to all other sites requesting that they prepare to update the database. The site don't update at this point, however, but they do send messages to the coordinator stating that they are ready to update. If for any reason any site can't secure the necessary locks, or if any site must abort its update, the site sends a message to the coordinator that all sites must abort the transaction. The coordinator waits for the replies from all sites involved before determining whether to commit the update. Another disadvantage of distributed databases is more difficult management of the data dictionary. Another disadvantage is also more complex database design and also more complicated security and backup requirements for the distributed database management system. With a single centralized database, we need to secure the central physical site, the central database, and also the network connecting users to the database at the central site. The security requirements for the distributed databases are actually more demanding, requiring us to secure every physical site and every database in addition to securing the network. Backing up a distributed database is also more complicated, and it's best initiated and controlled from a single site. Now let's look at 12 rules for distributed databases that the Computer World 2000 in 1987 mentioned. First, local autonomy. No site should depend on another site to perform its database function. No reliance on a central site. The distributed database management system should not rely on a single site to control specific types of operation. continuous operation. Performing functions such as adding sites, changing versions of the database management system, creating backups, and modifying hardware should not require planned shutdown of the entire distributed databases. Location transparency. Users should not be concerned with the location of any specific data in the database. Fragmentation transparency. Users shouldn't be aware of any data fragmentation that has occurred in the database. Users should feel as if they are using a single centralized database. Replication transparency. Users should not be aware of any data replications. And distributed query processing that the distributed database management system must process queries as rapidly as possible. And distributed transaction management is that the distributed database management system must effectively manage transactions update at a multiple site. Hardware independence is when organizations usually have many different types of hardware and that the database management system must be able to run on these hardwares. Without these capabilities, users are becoming restricted to access the data that is stored only on a similar computers or disks. Operating system independence is even when organization uses similar hardware, different operating system might be used within the company. For the same reason that is desirable for the distributed database management to support different types of hardware. Network independence, because different sites within the company might use different communication networks, therefore the distributed database management system must also run on different types of network and not be restricted to a single type of network. Database management system independence is another way of saying that the distributed database management system should be heterogeneous. That means it should support different local database management systems. And these are the 12 rules that basically we should follow when we are talking about the distributed databases.